In this second of the two videos, we'll end up getting into some word problems, some missing coordinates, and that'll do it. So I would consider this to be the applications part of the notes, where you get to see why you would use the distance formula. Okay, so this one's apparently about golf. Trey's golf ball is 20 feet short and 8 feet to the right of the cup. On her first putt, the ball lands 2 feet to the left and 3 feet beyond the cup. If the ball went in a straight line, how far did it go? Now right now, as you're probably picturing this, you're perhaps coming up blank. And because of that, it's good to always draw a picture as best you can, chunking sentence by sentence. Okay, so Trey's golf ball is 20 feet short and 8 feet to the right of the cup. So if something's to the right of something, then I guess it would be over here and the other thing would be here. So that means that the cup is going to be to the left. And if you're not much for golf, that's just where the ball ends up. So here, I'll make a little dot and I'll label this the cup. Now, if it's short and 8 feet to the right, well, I guess I'll make something end up 8 feet to the right, like that. And then 20 feet short, I'm assuming that means it's going like in this direction maybe. So that'll work for this drawing right here. On her first putt, so what happened is, like basically I guess she drove the ball and this is where it landed. On her first putt, the ball lands 2 feet to the left and 3 feet beyond the cup. So if you wrote cup exactly where I did, maybe it might be nice to relabel it, because now the ball is 2 feet to the left and 3 feet beyond. So it looks like we have a couple of triangles going on here. But we can either make these coordinates, or if you're feeling confident, we can treat these as, kind of just a little bit of a logic problem. So I know that the distance, and I'm going to write this lower here so that I got some room, is going to be how much the x changed. Well, looks like the change in the x direction, and here I'm not going to use the formula because I think it's going to complicate it. Like 2 over here and 8 over here, that's the total change in the x distance. Now, this would be like 8 minus a negative 2, so it's really 8 plus 2 if you wanted to stick to the formula. So I'll show 8 plus 2 squared, because that's how far they are away in terms of x. And then as far as y is concerned, it's going to be like 3 minus a negative 20, or however you want to think of it. So I'll end up adding 20 and 3, and then squaring that. Now, if you're overthinking this one, and it's bothering you, the way that I did it, then we can look at it and go about it a different approach. So 10 squared gives me that. 23 squared, I'm typing into the calculator, I get 529, and that would be the square root of 629. Now, if you end up finding yourself really trying out dividing this by 4 or dividing by 9, and it goes on a little bit too far, then it would be okay to approximate this with a decimal, because you might end up with a very, very large very large prime number. So when I type this into the calculator, I end up getting approximately 25.1, and we're not going to say units, because if I look, everything they gave us was in feet, and it's not like they're messing with us and giving us something that says inches, so we're not going to have to recalculate that at all. So I got 25.1 feet. Now this is a word problem, so maybe you want to do a little bit of a sanity check. So it's like, well, if I know that it traveled, and I guess I'll show this in red because it's just my thought process. If I traveled like, 23 feet vertically and then, maybe like 10 feet over, to me it seems like this number definitely has to be larger than 23. And it is, so maybe I move on feeling relatively comfortable. find a missing coordinate. Find the possible values of a if the distance between the points at 7, 5 and a negative 3 is 10 units. So if I were to rewrite this, I want to find the distance between 7, 5 and then a negative 3. Now, I already have the distance, so that distance is going to be 10 units. So if you wanted to, I guess, over to the side, you could be like, well, d is going to be equal to 10. And really, if you pause this, you could maybe teach this to yourself, because you would say, well, I know I'm going to use the distance formula. That's kind of the only new tool I have. So if I rewrite it, you could then say, well, did they give me all the information that I need to come up with this value of a? And they said something strange, possible values. So I think we can find out what that means in a moment. Well, I know what the distance is. That distance is 10, so I'm going to plug that in. Equals the square root. And I see 1, 2, 3, 4 separate values, and I know 3 of those. Well, I make sure I don't get tripped up. So I treat x first. So a and 7 are my x values. So in parentheses, I'll write a minus 7. You really want to make sure you keep minus there and make sure you don't make an error with minus and negative and things like that. My other one's negative 3 and 5, so I'll write negative 3 minus 5. And then I'll square that. So that now I have 10, and if you wanted to, you could square this now, but it's probably going to complicate it. So 10 is equal to the square root of a minus 7 squared. Maybe you're tempted to FOIL that out, but it's only going to make things worse. And the negative 3 minus 5 is negative 8, and I know I could square it now, but I'm going to end up showing my work. And then here's 10 equals the square root of a minus 7 squared plus 64. Okay, I have something weird with the radical in it. I can't just do this. This is totally not okay for me to subtract something that's under a radical. I'd have to take care of the inverse operation by squaring my entire radical and squaring 10. Left side becomes 100 is equal to, the square root's now gone away, so I'll write a minus 7 squared plus 64. Okay, now I'm liking the way these positive numbers are working out. Now when I subtract 64, it's looking like I'm going to get a nice number that I can square root, like 36. And that's going to be equal to a minus 7. Now here is where the possible values comes into play. Once I square root both sides, on the left I'll get positive or negative 6, and then my exponent goes away, and I'm left with a minus 7. Adding 7 to both sides means that a is now equal to, and I'll walk through this since it's been a little while. If it's a positive 6, I'd add 7 and get 13. And if it's a negative 6, I would add 7 and get positive 1. So my possible values for a are 13 and 1. And that's okay to leave that as your answer. Because if I go up here, they just want to know what are the possible values of a, and we found out that that could be 13 or 1. They don't need the finished coordinates or anything. But with this being a new type of problem, you could plug this in and see what happens. Now, I don't expect you to do this for every type of problem, but I think that as you teach yourself this stuff and make sure you're comfortable, it's not a bad call. So let's pretend a is 13, first of all. When I use the distance formula, I subtract that, and 13 minus 7 gives me 6, and then I could square it, and then along the way we knew that that was 36. And you could work it out by adding 64 and eventually getting down to 10. I'm jumping around a little bit, so this is like kind of the bonus push to challenge yourself. Now if I plug in 1, well, 1 minus 7 is a negative 6, and then I'd square that, get positive 36 again, add 64, get 100, and square root it and get 10. that's how you could do these problems. Now, we'll make this an on-your-own problem. The only difference is that you got square root of 58. And I do still want to see you showing the distance formula and plugging everything in. Earlier on, if you feel like squaring it, that's fine. You could do that like in this step, just as long as you know why that's okay. I'll put the answer up in about 5 seconds. I'll do a couple of scrolls through this just so you can keep track of it. Basically, plugging in the values. At this point, I ended up squaring it and evaluating this in the same step. Not a big deal. Square root of 9 gave me positive or negative 3, but the thing is, since I had set my problem up originally to have minus a in here, that means when I rewrote this here, it carried the minus sign with it. So that then if I flipped all the signs, this became a positive, but you don't really have to worry about plus or minus because it would just flip the other one. So I got 2 comma 8 as I did this. Unless I made a simple math error or something like that, it should be correct. So if you're not sure, type it back in instead with these 2 and 8s into Wolfram Alpha, and you can compare to see if you get the square root of 58. So this is all about the distance formula, and I think this will be a good section. Just keep out an eye for some of those small warnings like minus and negative, keeping track of plus or minus. Just small things can throw parts off. And of course, if you were to mix up x2 and x1, that would be possibly a problem. So like I said, this second video is more about the applications of these distance formula problems and concepts.